In this problem, it says a segment of a circle with radius 12 is determined by a 120-degree arc. Determine the area of the segment of this circle. And be clear, we want to express our answer as a decimal, rounded to the nearest thousandth. So here's a circle. They give us that the radius is 12. The central angle is 120 degrees. Now the segment is that piece, that region right here. So what we have to do is first we need to figure out the area of this sector. And so a sector is just a piece of the circle. And so to find the area of the sector, we take the area formula, pi r squared, and then we multiply by the portion of the circle that it takes up, specifically 120 divided by 360. Now 12 squared is 144, and 120 over 360 simplifies to 1/3. And when we take 144 and divide by 1/3, we get 48 pi. That's our area of the sector. But from that, we have to subtract the area of this triangle. And so what we've got is we've got 120 degrees. We've got 12, we've got 12. Now what I'm going to do is I'm going to take this and draw the altitude. Now since this triangle is isosceles, this also is the angle bisector. So that breaks this into 60 and 60, which breaks this into 30 and 30. So what we have is we have two 30, 60, 90 right triangles. So this side is the short side, which is 6, and then this is 6 radical 3, and this is 6 radical 3. So we can think of this as our base, and we can think of that as our height. So the area is 1/2 the base, it's 12 radical 3, times the height, which is 6. And so we get 36 radical 3. So then what we need to do to get the area of the segment is to take the sector, 48 pi, and subtract 36 radical 3. Now that would be our exact answer, but this question wants us to calculate this exactly. So 48 pi minus 36 radical 3. And so when we round that to the nearest thousandth, that 2 is going to be rounded up. So that means we're going to have 88.443. And there is our answer. And we're done.